countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all the teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah. And for the non-Muslim, please take a moment of silence. Okay, how is everyone doing today? So my prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself. I am Madam Rosmaya from SMJK Yuhua Kajang Selangor. Today I will present alone because my partner Madam Non cannot join us today. So before we start our discussion, so please subscribe to my channel, okay, so that you won't miss any of my new video in the future. So as usual, the lesson will last approximately for 1 hour. The certificate link and the credit claim link will be given at the end of this lesson. You can only use Didik email and more email to claim the certificate. So I will put the link Didik email, okay, in the chat box now. Okay, there you are. Okay, so be sure to follow the class up until the end and give your full cooperation in making this lesson a lively one. I would also like to remind students to use appropriate language and use appropriate profile picture, if possible, your own picture, if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any questions, please write in the chat box. So without further ado, I will announce the first letter and together with the 2-digit codes for credit claim. So the code is A27. Okay, A, letter A, number 2, another number is number 7. Okay, so now I'm going to open my slide. Okay, so let me introduce the pre-U teams that we have in Academy YouTuber. Okay, so this is Physics Pre-U, okay, lead by me. Okay, and another member, physics member is Teacher Hapsayu, Teacher Su and Teacher Non. We also have Maths team lead by Teacher Im. Biology Pre-U team lead by Cikgu Faiza. Chemistry Pre-U team lead by Encik Shahnun. And Perakaunan dan Ekonomi Pra-U team lead by Madam Fizi. Okay. Okay, so we also have apps. Academy YouTuber also has apps where you can download it from the Google Play Store. There are a lot of videos there, including the physics video. Okay, so now we have come to the main objective for today's live. Okay. We are going to do some revision on topics electricity from chapter 12 to 15, okay, by solving a few questions. So I have posted the link to the PDF questions in the description part below, okay, this YouTube video channel. and also in the chat box also there, the question PDF link. Okay, so let's start now. The first question. Okay, so those who have done the questions, very good. You can share your answer in the chat box. Okay, so let's check the answer. Okay, question number 1, we read the question first. Okay, the two positive charges with magnitudes 4Q and Q are separated by a distance R. So which of the following statements is true? So answer A given, the charge with a greater magnitude exerts a larger force on the small charge. So the charge with a greater magnitude exerts a smaller force on the small charge. C, the force on each charge are the same in magnitude and opposite in direction. And D, the forces on each charge are the same in magnitude and pointing in the same direction. So mentioned in the answer here, forces and charge. So that's mean we are going to use Coulomb's law. So memorize this formula. So the formula is electrostatic force is given by Q1, Q2 from these two charges divided by 4 pi epsilon naught R squared. So R is the distance between the two charges. Epsilon naught is the permittivity of the free space. Okay, so the force experienced by charge 4Q is to the left, to the left. Okay, why? Because like charges, they repel each other. Okay, like charges, they repel each other. So charge 4Q is to the left direction. We name this as F1. So we substitute into the equation here, the force experienced by this charge. So we get 4Q times Q per 4 pi epsilon naught R squared, distance given R. So you substitute whatever given in the question, the magnitude in symbol form. Okay, so Chia Yao answer C. Okay, so let's check what's the answer. So for charge Q also experience a force, it repel because these two is like charges, so they repel. So the direction of charge Q is to the right, F2. And when we substitute into the equation, so we see that the two answers, the two forces, F1 and F2 are the same. The same. Okay, so that's mean A and B is out already, the answer, but look at C and D. Both mention same in magnitude, but what about the direction? So you see the directions are opposite. Okay, so therefore the answer is C. Okay, so Chia Yao, okay, congratulations, correct answer. Okay, next we go to question 2. Question 2. Okay, so we read this question. Two identical solid metal spheres, okay, X and Y, are charged positively with Q1 and Q2, where Q1 larger than Q2, respectively. So which of the following statements is true concerning sphere X and sphere Y? Okay, you can write there your answer for this question. Okay. Okay, the answer A is the electric field strength on the surface of sphere X and sphere Y are 0. B, the electric field strength inside sphere X and sphere Y are 0. C, the electric field strength inside sphere X is more than the electric field strength inside sphere Y. And D, the electric potential inside the sphere X and sphere Y is 0. So we need to know the formula for electric field strength and electric potential. Okay, so how to imagine the question, explanation, state that this is a metal sphere XY. So the charge is Q1. Because this is metal, okay, if metal, the charge can flow freely through the metal. Okay, so the self-repulsion of charges will result in all the charge residing on the surface of the sphere. So the charge free to move. Okay, so it will reside to the surface, okay, of the sphere. And Q1 is larger than Q2. Okay, so this is how to imagine. Okay, so that's mean mention here electric field on the surface of sphere X and sphere Y are 0 is wrong lah. Okay, because there is a charge on the surface. Okay, from the formula formula is Q per 4 pi epsilon naught R squared. So the Q on the surface, there is a Q on the surface, charge on the surface. So A is not the answer. So B is the answer. Because the electric field strength inside the sphere X and sphere Y are 0. No charge inside the sphere. Okay. So therefore, electric field inside the sphere are 0. From the formula here, Q is 0. So 0 per 4 pi epsilon R squared give you electric field strength equals to 0. Okay, so C is not the answer because mentioned here more, right? And D, what about electric potential? Electric potential, the formula is Q per 4 pi epsilon naught R, but the definition from electric field is different, not the same as E, because V is the work done for the test charge to bring one charge from one point to the other point, or let's say this sphere. So therefore, it has value here. So you must know the difference between electric potential and electric field. For electric field, inside the sphere is 0. But for electric potential, inside the sphere, there is a value, okay, inside the sphere. Why? Because electric potential definition is the amount of work done when a charged particle, okay, another charge, not the sphere charge, okay, move from one place to another place in an electric field. So the electric field is provided by this sphere, X and Y. Okay, so D also is not the answer. It's not supposed to be 0. So that's the difference between electric field strength and the electric potential. Okay, so B, the answer. Okay, next we go to question 3. Okay, so we read the question together. Okay, so if you got the answer, you can share your answer to in the chat box. Okay, you can also join. Okay, Chia Yao, you answer number 2B, Okay, now number 3. So what's the answer for number 3? We read the question. The variation of current I with time T, okay, I with time T, when a capacitor is discharging. Okay, be careful with this mentioned in the question, discharging process. So what are the formula in your mind, for the formula for the discharging process of a capacitor, of the capacitor. Okay, so we are going to find time constant of the circuit. Okay, what is the time constant of the circuit? So what is the formula for the time constant of the capacitor? So the formula is RC, resistance times the capacitance. And for the discharging process for I, so you also must know the formula. And the meaning of time constant is, you must know the definition for time constant. So time constant is defined as the time it takes the circuit to reach 63.2% of the maximum or fall to 36.8% of the maximum possible voltage or current. This one is for voltage, this one is for current. So depends on the charging or discharging process. So for discharging, this is discharging process. For discharging process to fall to 36.8% is here, somewhere here. This is the graph. Okay, this is for charging graph. This is for voltage. Discharging. Sorry, voltage for charging. Okay, so this is the formula you must memorize. Remember that in the STPM not given. Okay, not given. So discharging because this is I against T, so I equals to I naught E to the power of negative T per RC. So you choose this formula. Okay, you get 36.8%. So how you get 36.8%? 63.2% is the charging part, the V here. Okay. Okay, so now we use this formula, the I, because the graph shows I against T. And the time constant formula is RC. So if you substitute into here, okay, this T time taken to get time constant is RC. So you will find that I equals to I naught E to the power of negative 1. RC per RC is negative 1. RC per RC is negative 1. So therefore, E to the power of negative 1 is 1 per E. So the value of E is 2.7 something. You can use your calculator, the value of E, and you get it's 0.368 I naught from the initial value of current. So that's when you convert to percent, becomes 36.8%. This is how you get it. Okay, so now refer to the graph. Okay, refer to the graph I against T. The initial current I naught is 10. You see, it's 10. So you substitute this 10 into here. Okay, then you get is 3.68 microampere. Okay, because here unit is microampere. So refer to the graph, 3.68 there, 3.68 there, give you reading for time 20 seconds. So therefore the answer is C, 20 seconds. Okay, the answer is C. Okay, Chaya, you know where you gone wrong already, So it's C, okay? Because time constant is equals to RC. So the I becomes 0.368 of the initial value. So initial value is given as 10. So when you calculate, you get 3.68 from the graph. The reading give you time 20 seconds. So this is the time constant, 20 seconds. Okay, so we go to the next question. So those who get right also can join there, saying that you understand or you don't understand. You can ask there in the chat box. Okay, next we go to question 4. Question 4. Okay, so the variation of the resistivity of a material with temperature is shown in the graph below. So resistivity against temperature. So the most likely material is, okay, what do you think? The material to show of this graph, decreasing. As the temperature increasing, you see that the resistivity decreasing. Okay, so there are three kinds, metal, semi-metal, semiconductor, and superconductor. So you must know the graph for conductors is like this. When temperature increases, the resistance increases, and therefore resistivity increases. Okay, so the graph should be like this, increasing graph. But for semiconductor, it's opposite of the conductor. Okay, when temperature increases, the resistivity decreases. Okay? And special for superconductor, is conductor but it's called superconductor because at certain temperature, we call this critical temperature, the resistivity will suddenly drop to 0. Okay, this is for superconductor. So now check, the graph is similar to this graph is semiconductor. Okay, the answer is B. Okay, semiconductor. Okay, so we go to the next question. Okay, question 5. Okay, if E is the magnitude of a uniform electric field in a conductor, tau, the symbol is tau, not T. Tau is the mean time between collision, and N is the number of free electrons per unit volume in the conductor. E is a charge and M is a mass of electron. So then the term Ne squared tau E per M is equal to the, so which one? This term shows which one? Okay, so we have here time, electric field. We start with the electric field. Okay, so if imagine the circuit here. Okay, and let's say this is a copper wire or any metal. So actually the flow of current is not just one flow. Actually there are many electrons, seas of electrons flowing through the circuit. So what happened is the the electron current is flow of electron, so electron flow from the terminal negative to the terminal positive. So as it flows to the left, right to the left, so it will collide with the atoms of the metal itself. So this happens when the electric field is applied. Electric field is in the direction of terminal positive battery, okay, the cell here, to the terminal negative. So electric field is in this direction. Okay, when the electric field is applied, the electrons initially accelerate, but soon reach a more or less steady state average velocity. We call this as drift velocity. Okay, we call the velocity as a drift velocity, and this drift velocity is due to the electrons colliding with the metal atoms in the conductor. Okay, so now back to the question. We have current density here, so sometimes there is a clue in the answer here. We start with current density. J is I per A, so I we can use NEVA. Okay, NEVA. So this one, NEVA, I never, the formula is easier to memorize as I never. I prefer to memorize as I never. So I told my student to memorize as I never. It's easier to memorize. We can cancel the A. Okay. Next, the problem is V. There is no V in the terms here. N is squared tau E per M, no V. So we need to continue to find V. So we can relate with the electric field. Okay. So from the force equals to EE. Okay, EE. So F is MA, and we can get acceleration equals to EE per M. So acceleration we can relate with V, okay, V. So it's V per tau here. Tau is the mean time between collision. So drift velocity divided by tau, the mean time between collision. So it equals to the E charge of electron times E per M, and cross multiply, we get this one, and we substitute into here, and we get the terms as is equals to the current density, current density J. So you see, the terms is N is squared, mean time between collision, electric field per mass of the electron. So the answer is C. That's how you get the answer. Okay, done for question 5. Okay, next we go to question 6. Okay, question 6. Okay, we read the question first. The two copper conductors have equal length. Okay, equal length. The cross-sectional area of one conductor is 4 times that of the other. So if the conductor having smaller cross-sectional area has a resistance of 40 ohm, the resistance of other conductor will be, okay, so we list what we are going to, what mentioned in the question, and remember the formula, repla, okay. The formula here easy to memorize as repla. R resistance equals to resistivity, length of the wire, divided by cross-sectional area of the wire. Okay, so in this case, resistivity is the same because it's the same conductor, two copper conductors, so same conductors. So resistivity is the same, equal length, also they have same length. So therefore, R is inversely proportional to A. So the changes is in between resistance and cross-sectional area. Okay, so that's why we use this relationship only. Or you can form two equation and use ratio method. These two symbol variable can be cancelled out. Okay, so the faster way is using this method lah, easier. R inversely proportional to A. Okay, same resistivity, same length, and the area 4 times, conductor 2 4 times of the other. So we can write as one is A1, the other one is 4A1. Okay, 4 times. Okay, what the rest of the information is 40 ohm. So this conductor 1 has resistance 40 ohm. The other we don't know. Okay, we are going to find R2. Okay, so from the variation method, you've learned in Form 5, okay, variation method. So this is inverse. R is inversely to A, inversely proportional to A. So you can write R1 per R2 equals to A2 per A1. Okay, so you substitute the values here to the equation. So R1 is 40, R2 is what we are going to find, A2 is for A1, A1 remain as A1. Okay, then you solve for R2, A1 can be cancelled out and you get R2 10 ohm. Okay, that's the answer. The answer is D. Okay, congratulations to those who have the answer D. Okay, so next question. Okay, next question, question 7. We read the question together. If R1 equals to 2 ohm and then R2 is 4 ohm, okay, this one, R3 is 6 ohm. So determine the electric current that flows in the circuit below. So E1 is 10 volt and E2 is 5 volt. Okay, so what's the answer? So for this question, you need to use Kirchhoff law. Okay. So remember that there are two laws. There are two laws for Kirchhoff law. The first law mentioned that the total of current equals to 0. Okay. For the currents to enter a point, okay, in a circuit is 0. Okay. So this one is based on the principle of conservation of charge. Okay. And for second law, okay, the total of product of IR is equals to the total of EMF. Okay, this E is not electric field. This E is the EMF here, 10 volt, 5 volt. There are two EMF here. Okay, they are equal. This one from a closed loop. Okay, the algebraic sum of the products of current and resistance equals to the algebraic sum of the EMF in the loops. Okay, this law, second law of Kirchhoff law, comes from the principle of conservation of energy. Okay, based on principle of conservation of energy. So because the circuit here only involve series circuit, R1, R2 and R3 all in series. So therefore we just use second law. No need to use first law because current is constant. Okay, current is constant. So that means we just use second law. So for second law, how to use second law? So you need to choose a loop, closed loop. So let's say the loop you draw is a clockwise loop. Okay, you can also draw anti-clockwise, but just choose one. Okay, I choose clockwise. And then direction of electric field for E1 is from terminal positive here to the right. And for E2, terminal positive also to the right. Okay, electric field. Okay, then for the EMF, they are opposite in direction. So for 10 volt, same direction as the loop, positive 10. And for 5 volt, opposite direction. Okay, with the loop. Electric field for E2 is opposite direction with the loop, you see. So it's minus. So 10 minus 5 for the product total of EMF. Okay, so 10 minus 5. Okay, what about the product of IR? So because the R1, R2 and RT is in series, okay, that's mean 2 plus 4 plus 6. R1 plus R2 plus R3. So they are in series. One way, current goes one way. So therefore I bracket 2 plus 4 plus 6. Okay, so the answer you get 0.42 ampere. Okay, the answer is A. Okay, Chayao, the answer is A for number 7. So next we go to question 8. Okay, question 8. Okay, so the figure shows a section of a circuit between the points K and L, where a dry cell of EMF 1.5 volt, okay, and internal resistance 0.5 ohm is connected in series with 4 ohm resistor. A current of 0.20 ampere flows from K to L. Okay, the potential at K is 3.6 volt. Okay, the potential at K. So what is the potential at point L? So how to do this question? So we are going to find potential at L. So we name as VL. Okay, we name as VL. So VK is 3.6 volt. So remember that you've learned in Form 4, Form 5 that the current flow from high voltage to low voltage. So that's mean the current flow, this way. Yeah, you see given in the question this way to the right. So that's mean VL must less than K. So 3.6 volt is at K. So that's mean at L must less than 3.6. Okay, that is what must have in your mind. Okay, must less than 3.6. So if you got your answer larger than 3.6, there must be something wrong in your calculation. Okay. So therefore, this one VL less than VK. Okay, so we bring down here to find the potential difference between K and L first. Because we have resistor here 4 ohm and 1.5 volt, another internal resistance. So we calculate first the potential difference between K and L. So between K and L, the EMF is given only 1, okay, 1.5 volt. Whereas the product of IR is 4 ohm times current. This is one way. So that's mean the current is constant, 0.20. So the first one, resistance 4 ohm, IR. Another product of IR is R from the internal resistance, 0.5. So 0.5 times 0.2. Okay, so this is the total of product of IR. They are in the current is in the same direction. So therefore the answer is 0.9 volt. Okay, now the difference between these two will be 1.5 plus 0.9. So why plus? Because look at the electric field. Okay, so the electric field from this 1.5 volts is the same as the current. Okay, same direction as the current. You see, same direction, that's why plus. If different direction, you minus. So same direction, you plus. So that's mean the total of potential difference between K and L is 2.4 volt. Okay, 2.4 volt. So for the VL, electric potential at L will be 3.6 minus 2.4. So that's mean you must minus. You cannot plus, because if you plus, you get larger value than 3.6. So you must minus 3.6 minus this 2.4, the potential difference between K and L. So you get 1.2 volt. So the answer is the V at L is electric potential at L is 1.2 volt. Hi Cikgu Non, thank you for dropping by here. Okay, Waalaikumsalam Cikgu Non. Okay, so the answer you check must less than 3.6. Remember that current flow from high voltage to low voltage. If you plus, you will get higher than 3.6, which is impossible. Okay, the answer is impossible. Okay, so that is question number 8. Okay, so I think we are already in the half of the our life today. So we rest for a while for the advertisement But before we take a break, okay, I would like to announce the third digit code. So the digit code is number 1. Okay, the digit code is number 1. Okay, so iklan, advertisement now.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so hi, welcome back to our free tuition live. Okay, so before we continue, I would like to announce the fourth digit code for credit claim. So the code is number 2. Okay, the code is number 2. Okay, so we have one more code for you all to collect, to jot down for the credit claim. Okay, so now now we go to this question, question 9. Continue with question 9. Okay, let's read the question together. A potentiometer, okay, this potentiometer is used to determine the EMF and internal resistance of cell E2. Okay, this is cell E2, shown in the diagram. So the battery E1 has EMF of 2 volt. Okay, this is E1. It has a negligible internal resistance. The sliding wire AB is 100 cm long. So be careful, read the question. AB 100 cm long. Resistance of the wire AB is 4 ohm. Resistors R1 and R2 have resistance 1 ohm and 5 ohm. Okay, this is R1, this is R2. The balance length of the wire is 85.0 cm when switch S is open. Okay, this one open, 85 cm. When close, 75 cm. Okay, so determine the potential difference per unit length across the wire AB. Okay, so B1 determine the EMF of cell E2 and B2 calculate the internal resistance of cell E2. Okay, so we do 9A first. Okay. So determine the potential difference per unit length across the wire AB. So you can forget for a while the circuit, the outside circuit just now. These are two circuit. One is for potentiometer part. The other one is the outer circuit. So we are going to find the potential difference across wire AB. So you can forget for a while the outer circuit. So for AB, so this is circuit from potentiometer. We can calculate the potential difference across AB. So we can directly use formula potential divider. Okay, use potential divider formula. So very simple. The voltage across AB is equals to the ratio of the resistance. AB is 4 ohm. Resistance 4 per total of resistance 4 plus 1. So across AB is 4 ohm. So 4 per 4 plus 1 times the EMF. EMF is given as 2 volt. So this is voltage across AB. So you can directly use potential divider formula. Very simple. So the answer is 1.6 volt per 1 meter because AB is 1 meter. Okay, 1 meter. The question asks potential difference per unit length. Okay, so AB is already 1 meter. So 1.6 volt per meter. Okay, so now we go to question B. Okay, back to the circuit here. The question B asks to determine the EMF for cell E2. This E2. Okay, so for EMF for the cell E2, okay, we are going to use 85 centimeter when the switch S is open. Because if this switch is open, so we don't care of the resistance R2. Okay, because no current flow here. S is open, S is open, the switch is open. So we don't care about the R2. So we can forget the R2 for a while. Okay, so the voltage across AJ is therefore equals to the voltage across E2. So we can find the MF for cell E2. Okay, so the V across E2 will be equals to the V across AJ. Okay, for V across AJ, you can use the potential divider formula, which is from potential the length 85 divided by 100. Okay, 85 divided by 100, and the voltage here comes from A because we have resistance here. So the voltage here 1.6 you can substitute into here. The balance length divided by 100 times the voltage from AB, which is 1.6. Okay, this is from potential divider formula. Can straight away use potential divider formula. So therefore EMF E2, cell E2 is 1.36 volt. Okay, so 1.36 volt. Okay, so that's the answer. Okay, 1.36 volt. Okay, next we do question 2. So we put this here because we are going to do the next question. Calculate the internal resistance of the cell E2. Okay, internal resistance of E2 has internal resistance. E2 is 1.36 volt as we have done just now, B1 1.36 volt. And this one we choose the second one because we need R2 to get involved because it has internal resistance. So when this switch is closed, okay, the balance length is no longer 85 but it's become 75 centimeter. Okay, so close the switch and the voltage across AJ now is equals equals to the voltage across R2 because here we don't know R, internal resistance, so we use R2 instead because R2 we know 5 ohm but R we don't know. Okay, R we don't know, so that's mean we choose the voltage across AJ equals to voltage across R2. It's easier, voltage across R2 is equals to voltage across AJ. I repeat, you can also use here, but to use here we don't know R. So we choose 5 ohm is easier because we can use potential divider formula. Okay, using potential divider formula for AJ, we can use from A just now. Okay, 1.6 and not 1.6 because now change already 75. So 75 per 100. Okay, times 1.6. Okay, 4 per 4 plus 1 times 2 from voltage across AB, right? So 4 divided by 4.1 times 2. But the balance length 75 per 100. So now voltage across R2, okay, this R2 will be 5 per 5 plus R. Again, we use potential divider formula. Right side is for the potentiometer. So for the left side is from the outside circuit here. The potential divider, we use ratio R2 per R2 plus R, which is 5 per 5 plus R. And the EMF calculated just now is 1.36. You see, very simple if we use potential divider formula. Okay, so you calculate, cross multiply. The rest is all mathematics. This is physics concept. So the answer is 0.67 ohm. Okay. You can also use the formula you've learned in Form 4, Form 5. Okay, or you can use the formula Form 4, Form 5. So VR2, but you need to calculate one more step to find current. So it's a longer step. So you can calculate I first. So the second method use longer methods because you need to calculate current first in here. Okay, so V across R2 will be 7 per 100 times 1.6 from here, okay, from the potentiometer, so you get 1.2 volt. So for this outer circuit here, this outer circuit, we use V equals to IR. So the current we get, okay, the current VR2 is 1.2, okay, divided by 5. So we get current is 0.24. Okay, the current is 0.24. So you calculate the current first. Okay, next you use E2 equals to the I R2 plus R. So this one formula you've learned in form 4.5, this formula. So E2 is 1.36, okay, from the cell, and because of the loss of current by the internal resistance, loss of EMF, loss of EMF by the internal resistance. So this R, so therefore 0.4 times bracket 5 plus R. So you get R, same answer, 0.67. Okay. But using the potential divider formula straight away is the easier method, because you don't need to calculate current to get this internal resistance. Okay, so done for question 9. So next we go to question 10. Okay, question 10. Okay, question 10, let's read the question together. 2 point charges, okay, Q1, negative 6 microcoulomb, Q2 also negative 6 microcoulomb, are placed at vertices of an equilateral triangle ABC, okay, as shown in the diagram here. So this is equilateral triangle, 10 cm. All sides have equal in magnitudes, the length. Okay, find the resultant electric field strength due to Q1 and Q2 at the point C of the triangle. Okay, at point C through the triangle. So how to do? To find electric field, okay, you must know the direction of electric field for negative charge or positive charge. So Q1 is negative charge. So the direction of electric field is radially inward. Okay, radially inward. So that's mean from point C, you draw the electric field towards the Q1, because the direction for negative charge is radially inward. So you draw E1. Okay, same things you do for Q2, also negative charge. So is the direction of electric field is radially inward. So from point C, you draw E2. Okay, E2 must be drawn on the line joining point C and point where the Q2 is, point B lah. Okay, must draw along this line joining them together. Okay, so now you know the direction of E1 and E2 already. Okay, next you can use resultant parallelogram method to find the resultant electric field, which is vertically downward. Vertically downward. So how you know that it is vertically downward? How you know? Because E1 and E2 is equal in magnitude. They from the formula formula of electric field strength, Q per 4 pi epsilon naught R squared. So Q is constant, or Q is they have same Q, 6, both have 6. Then 4 pi is a constant, epsilon naught is a constant, and R, distance between them also constant, same, 10. So that means E1 is equals to E2. If they are equal, so that means the ER must, the E resultant must be downward, vertically downward, straight, downward. Okay, so the angle is 120 degrees between here. How you know? Because this is equilateral triangle. So all the angles inside the equilateral triangle is 60 degrees. 60 degrees. So therefore the angle here is 120 degrees. Okay, so the best method to calculate ER is you can use cosine rule. Okay, you remember cosine rules you've learned in at maths, in form 4.5, okay, at maths, cosine rule. So E resultant here is square root of E1 squared plus E2 squared minus 2E1 E2 cos 120 degrees. Okay, angles between E1 and E2. Yeah, 120 degrees. Okay, this is the faster way to get E1, ER. Another method you can use resolution method of the E1 and E2. Okay, can use Cartesian plane and resolve the component for E1 and E2. But that one is more complicated to do lah. So better use cosine rule straight away. Because you know already ER is vertically downward. So can just get the magnitude, calculate the magnitude using cosine rule. Okay, so now substitute everything, and instead of substitute, we calculate we use E1 is equals to E2, right? So we just use one variable instead of E1 E2, so we just use E because they are the same. E1 and E2 is the same, so E, and solve, you get square root of 3E squared, which is 3 square root of 3 or 3E lah. Or it's up to you lah, how whatever you do. Is the simpler one is actually E, but it's okay, follow this also can, you get same answer, not worry. Okay, so the Q is 6 microcoulomb, convert to coulomb. 4 pi epsilon naught is 8.85 times 10 to the power of negative 12, and the distance between them is 10 cm. 10 cm, convert to meter. Okay, squared, don't forget squared. Then again here E squared, E squared, and you get answer is answer is 9.34 Newton per coulomb. Okay, and don't forget direction is vertically downward. Okay, not? Okay, if you got any problem, you can ask there in the chat box. Okay. Okay, so that's the answer. Resultant electric field 9.34 Newton per coulomb. Vertically downward. Okay, next we go to question 11. Question 11. Okay, the figure below shows a charge positive Q. This one is positive Q. Another charge negative Q, fixed at a point A and B, separated by a distance of 12 centimeter here, 12 centimeter. A to Y is 3 centimeter, A to X 5 centimeter. Okay, charge Q is 2 microcoulomb. So Q is 2 microcoulomb. So determine electric potential at point X, at point Y, and also determine the work done to bring a charge of 5 microcoulomb from X to Y. Okay, work done. So we calculate number 11.1 first. So what is the formula for electric potential? Okay, what is the formula? So the V at X, okay, to calculate electric potential, very simple. You just add the electric potential comes from A and B. So VA plus VB. Okay, so the formula is Q per 4 pi epsilon naught R. So R no square for R. Okay, so you use this formula, and for VA, distance is 7 from B. B is 7 here, and then the VA from A is 5. So be careful with the distance. So X to A is 5 centimeter, X to B is 7 centimeter. So you substitute everything, both is 2. But to calculate electric potential, you must bring along the sign. So VB, B is negative Q, so bring along the negative together with the magnitude. So negative 2 times 10 to the power negative 6. Okay, convert to meter. Okay, now the answer is electric potential at X is 1.03 times 10 to the power of 5 volt. Okay, so we put here and find the electric potential at point Y. So you do the same. Okay, So you just total VA plus VB, but this time using the formula here, distance will be different. So distance will be A to Y will be 3 centimeter and Y to B will be 9 centimeter. So be careful, don't make careless mistake. Okay, 9. And another one, bring along the negative sign if the charge is negative charge. Okay, that's how to calculate electric potential. Okay, so the answer is 4 times 10 to the power of 5 volt. Okay. Okay, then work done. So work done to bring charge of 5 microcoulomb from X to Y. Okay, this time we have a charge to bring we bring the charge from X to Y. Okay, X to Y. Okay, so bring X to Y. X to Y. So which one is final, which one is initial? So remember the work done from the formula of work is QV. Work is QV. So charge times the V, electric potential. So work done is QV final minus QV initial. Okay, QV final minus QV initial. So you must know from where to where, X to Y. So which one is final, which one is initial is very, very important. If not, you will make mistake with the answer because of wrong sign. So work is QV, so that's mean QVF minus QVI. Okay, the charge you bring is 5 microcoulomb. Okay, 5 microcoulomb. So substitute this 5 microcoulomb, convert to coulomb. And then the VF, okay, this must be very careful. So for VX just now, VF is final is Y. So that's mean you you substitute into here. VI is initial X, so that's mean VX here 1.03, you substitute here into here. So this is where you need to be very careful. Which one is VX, which one is VY for final and initial electric potential. Okay, then you get the answer 1.5 joule. Okay, 1.5 joule. Okay, that's the work done. Okay, next. Done for question 11. Okay, next is question 12. Okay, a parallel plate capacitor is charged to a voltage V and then disconnected from the supply. So the space between the plates is then filled with an insulator. So explain in molecular terms the change in the electric field between the plates and hence deduce the change in the capacitance of the capacitor. Okay, explain in molecular terms. So imagine the parallel plate here. Okay, it is charged to V, voltage V, and disconnected from the supply. So we disconnected from the supply. So therefore, it has electric field between the plates. Okay, the direction is from positive plate to negative plate. This is direction of electric field. Okay, so we are going to insert the dielectric, which is an insulator, okay, into the plate. So what happened? This is before the dielectric is inserted. The polar molecules in the dielectric without electric field is at random direction. Okay, positive and negative, the polar molecules. But once you insert, so they will arrange themselves according to the plate. If positive plate, this way, so the molecules will be polar molecules will be oriented like this, negative to positive side. They can just oriented at their own place, the molecules, because this is insulator, so it's not free to move in the charge, not free to move in the insulator. So that's why we call this process as a polarization. Okay, polarization. So what happened is it creates another electric field here, electric field in the dielectric. So molecules of the dielectric are polarized by the electric field between the plates. You mentioned this, okay, the explanation. So molecules of the dielectric are polarized by the electric field between the plates. Okay, next, a resultant field strength is set up in the dielectric. So the original is E, but the resultant will be less. You must mention the resultant electric field that is set up in the dielectric will make the resultant electric field less than the original E just now. Okay, so the resultant electric field is weaker than the initial electric field. Okay, that is what happened. Another word is electric field is decreasing. Decreasing. Okay, so question 2. Hence deduce the change in the capacitance of the capacitor. Okay, so this one you need to use the formula E equals to V per D for the plates, for this plate. So E equals to V per D for the capacitor here. D is separation, plate separation. V is the voltage across the plates. So if the E weaker, right? So when the electric field decreases, E weakens, that means electric field decreases. What happened to the V? So the potential V also decreases. V between the plates is reduced. So E decreases, V also decreases. Okay, you must mention this. Then what's next equation to be used is Q from Q equals to CV. So because we are going to relate with the capacitance. So when V decreases, charge is constant because the charge cannot go anywhere. Because the capacitor is mentioned here, disconnected from the supply. So the charge cannot go anywhere. So the charge is constant. It's still maintained in the capacitor. Capacitor. So the charge constant, C and V change. C and V change. So when V change, which is decreasing, so capacitance increases. Okay, from the relationship here. So when V decreases, capacitance C increases. You can see from the equation here. Okay, inversely proportional. So V decreases from the first equation, V decreases, and from the second equation, because the V decreases, capacitance increases. So this is the answer. What is the change in the capacitance? The capacitance increases. Then you get full mark. Must mention everything here. Okay, so done for question 12 too. Okay, mention also the charge remain constant. The charge Q remain constant for another mark, full mark. Okay, then question 13. Okay, the area of each plate of the plate capacitor is A. Then the space between the plate is filled with an insulator. Dielectric constant is given 7. Thickness is D, or plate separation. Separation between the plates D. And the capacitor charged to voltage V, and then disconnected from the supply. Then the dielectric is slowly pulled until only half of the space between the plate is filled with the dielectric as shown below. So this is initial, this is final situation. So write expression for the initial capacitance C naught and the effective capacitance C when only half of the space between the plates is filled with dielectric, and explain the change in the energy stored. So for 1, so the formula we use is C equals to epsilon A per D. Okay, but we have dielectric, so the epsilon is epsilon R epsilon naught, because we have dielectric. So we must use the symbol given C naught. The symbol given C naught, so you must use C naught. So epsilon R is 7, epsilon naught, A is A given as A. You must use the symbol given in the question. Cannot use your own symbol. And D. Okay. Then the answer is 7 epsilon naught A per D. Okay, this is C naught for this first situation. So second situation is when the dielectric is full. Then and the supply is disconnected. So we use C equals to C1 plus C2 because this is equivalent to the when you pull the dielectric, so actually there are two capacitance here, C1 plus C2. This is equivalent circuit for this one. So the C1 and C2 is parallel. So therefore we use the formula capacitance arranged in parallel. The formula is C1 plus C2. Okay, for C1 is where the dielectric is in air. So epsilon naught, but the area now changed to half A. Given earlier is A, so dielectric is pull half. So that means the area become half, but the distance still the same. For C2, area also half, and the dielectric constant is 7 epsilon naught per D. Then you solve. Okay, so you get this. And simplify, you get 1 per 14 C naught plus 1 per 2 C naught. So your answer must in terms given C naught here. So you get 4 per 7 C naught. Okay, 4 per 7 C naught. Because given here C naught, so that's why the effective capacitance must be answered in terms of C naught. So it's become 4 per 7 C naught. Okay, so capacitance is decreased. Capacitance decreases, is no longer full. C naught, so becomes 4 per 7. Okay, so that is question 1. For question 2, so we keep this here because we are going to use this for the next question. So explain the change in the energy stored. So the energy stored formula is half QV, half CV squared, half Q squared per C. So which one to choose? Because in one you calculate C and the charge is constant, and because from the question 12 just now also mentioned already, if the capacitor is disconnected from the supply, so the charge cannot go anywhere. So the charge is constant, remains the same as in the plate capacitor. So Q is constant, so that's why we choose this instead. So U equals to half Q squared per C. Here you cannot choose because the V change, the V change. So you cannot use V. V also not given. This V change already. Initially charge V, but when you pull the dielectric, V change already. So not given. So you choose third equation formula for energy stored. Okay, charge conserved, energy change with capacitance, and when capacitance decreases, what happens? Capacitance increases, the potential difference between the plates increases. So therefore, the C capacitance decreases. Capacitance decreases, charge remain the same. So the answer is the capacitance decreases. Now we are going to relate with energy. When the capacitance increases, therefore the energy stored increases. Okay, can see it inversely proportional. So C decreases, U increases. So if you want to calculate the answer, the change, you can write in terms of change in energy. So calculate the change in energy. You will get positive value because the energy stored increases. So let's calculate together. So change in internal energy is U final minus U initial. So you use this formula. So half Q squared per C for initial, and then for final DC, and then for initial C naught, and substitute this C into here. Okay, so you substitute 1 per C DC into here. Okay, this is what you get. 4 per 7 C naught becomes 7 per 4 C naught. Okay, 1 because 1 per C. So you simplify, you get half Q naught, 3 per 4 C naught. So the final answer is 3 per 8 Q squared per C naught. So it's reduced. You get a positive value. It's not minus. So if positive, that means the energy stored increases. Okay, and the change in energy is positive 3 per 8 Q squared per C naught. Okay, not? So that's the change in energy stored. Okay, so that's all for today until question 13. Okay, I give you. And we finish. Okay, we finish. So with God grace, we have reached the end of today's lesson. So congratulations to those who are able to follow the lesson from the beginning till the end. So before we end our session today, I will announce the last digit code for credit claim. So the digit is number 4. Okay, the digit is number 4. So all of you, please stop posting your comments for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson next week. Okay. Then if you find that the lesson is beneficial, so click like and share to your friends. Spread and share the goodness. Once completed, type done on the chat box, and before certificate link is given as a token of thank you for your dedication in joining the free online class today. So I will put the link of the certificate and credit link in the chat box. So I copy and paste it in the chat box. For the link sijil, another one is the link credit. Okay, done. And my username is Rosmaya 70. Okay. So please take note that the link will end half an hour after this live. So make sure to use the EDD email and more email only, okay, to log in. Incorrect email use will not be entertained. So if you haven't got one, you can apply for the EDD email. Okay, so if you wish to get more information on the online classes, go to the www.academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. You are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. So this is the collective effort from all teachers throughout Malaysia, for all the students throughout the country. And thank you for being a YouTuber Academy supporter too. So I think that's all for now. See you another lesson. Remember the hashtag with the hashtag bermula percuma and selamanya percuma. So Assalamualaikum. Stay safe till we meet again next week. Every Sunday, next week Sunday at 5 p.m. And bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.